right, today it is 11:18, and we're talking about sequences today. So all a sequence is basically a list of numbers in a pattern, okay? In a pattern. They need to be in a pattern, otherwise it's just random numbers. It has to be a sequence, you have to have some pattern going on, whether it's plus 2, plus 2, plus 2, minus 10, times by 3, times by 3. There's got to be some pattern, okay? So example 1 says create the first 5 terms. Well, here's how it works. N is always going to equal these numbers. 1, 2, 3, 4, 5, ... And the reason we want n to represent those numbers is because when we plug in 1, we make the first term. When we plug in 2, we make the second term, and we plug in 3, so forth and so on. So let's make the first term. So I plug in 1, and 1 goes in for n. In fact, 1 goes here, A1, and it goes here. So we go A1 is equal to 3 times 1 plus 1. So A1 is going to be 4, right? A2 is going to be 3 times 2 plus 1, because I plug in 2, right? Caden. A2 then is 6 plus 1 is 7, so A2 is 7. A3 is 3 times 3 plus 1, which is 10. Do you see a pattern yet? So far I've got 4, 7, 10. I mean, I can make the next term, but does anybody see something that's going on? Yeah, we're just adding 3. You guys see how we're adding 3 each time? But if you don't see that, you can just keep making it, right? You can make a 4 is going to be a 3 times a 4 plus 1, which is 11, 12, 13, right? And then a 5 is 3 times 5 plus 1. 15 plus 1 is 16. And you can see then basically what we've done is we're just adding 3, adding 3, adding 3, right? Which is a little confusing because when you see the 3n, you're thinking multiply. But what you really are doing is by putting in another 3 each time, okay? Example 2, okay? N squared plus 2n plus 1. Okay, so let's see. We're going to plug in the first 5 terms. We'll go A1 is going to be a 5 squared plus a 2 times a 5 plus a 1. Okay? 25 plus 10 is 35, 36. Okay? How's that? Now I might need a calculator to do some of these. I can do that. A2, just plug it in. I'm going to have wow, nobody caught. That's A5. It's morning time, isn't it? It is Monday morning. I just made A5, didn't I? Jumped right to A5. Wow. 1, 1, 1. That's first 5 terms. Interesting.
4.
Yeah, 1 plus 2. How about 4? Thanks, Isaac. A2. Let's plug in 2, not 5. 2 squared plus 2 times 2 plus 1. 4 plus 8, 9. 4 plus 4 is 9. Thanks, Isaac. A3 is 3 squared plus 2 times 3 plus 1. Is it 16? I'm going to believe you because obviously my brain didn't work there. A4 is 4 squared plus 2 times 4 plus 1. What'd you get?
25.
25.
Next one will be 36.
Probably. Yeah, actually we made 36, didn't we? Kind of weird, huh? I can show you why, but it's okay. 2 times 5 plus 1, which is 36. Okay? Not too bad. And again, I like to write them in a list. You don't have to, but I like to say, okay, I've got 4, 9, 16, 25, and 36. Okay? Thumbs up? Okay, pretty easy. Now, formula. The formula's a little bit harder.
Isn't it n plus 1?
What I noticed right off the bat, and if I go back all the way, let me go back to example 1, okay? Example 1. So in example 1, I was adding 3. Before I do anything, example 1, I was adding 3, but you see the 3n? because really multiplication is just like grouping addition. So in this one, I'm thinking 5n.
Yeah.
I'm thinking 5n. So if I go a of n equals 5n, then when I add in 1, I get 5, add in 2, I get 10, 3, I get 15. So I really am going up by 5s. Does that make sense? Well, I got to make an adjustment. So if I plug in 1, right now, I'm not going to get 1.
So it's just 5n plus 1.
So if I plug in 1, I get 5, but if I want a 1, let's go ahead and subtract 4. Let's see if that works. So this is where it gets hard because you got to think. I think it's always a bummer, but check it out. So if I plug in 1, 5 times 1 is 5 minus 4 is 1. Plug in 2, I get 10 minus 4 is 6. Good. If I plug in 3, I think it's going to work, right? Okay, so there's my formula. Now, to find the 20th term. Well, I got a formula. So instead of going through and putting it in, making it, let's just use our formula. So I can plug in 20 to make the 20th term. So once I get a formula, I'm going to use the formula I just made, right? So I'm going to go a to the 20. A lot faster than making all the way to the 20th one. That'd be a drag, wouldn't it? Just plug in 20. I get 5 times 20 minus 4. I get 100 minus 4, which is 96, right? Oh, that was great. Once you get a formula, you go straight to it, okay? Thumbs up. Thanks, Julia. Okay, ready to turn it over? All right. All right, let's see what we've got. So, create a formula for this sequence. I've got 1/4, 2/4, 3/4. Well, I know n, which is going to help me out. A little hint. N is equal to, I think Caden's got it. Okay. So, if n is 1, 2, 3, 4, and on the top of this fraction I've got a 1, 2, 3, I know my formula is probably going to have just an n on top. Because I'm plugging in 1, then I plug in 2, then I plug in 3. Nice job, Caden. What's on the bottom of this formula? It's always 4, isn't it? It's always 4, so it's just n over 4. Now if I want to find the 10th term, that's easy, right? Got a formula? Just plug it in. Plug into my formula. All right, this is going to be great. So go A10 equals 10 over 4, and that's my answer, or 5/2, or 2.5. Okay. All right, 5. Let's see what I have. So I got these numbers. I've got a 4, right? And then let's see, it's 1, 2, 3, 4, 5, 6, 7, 8. I've got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I wonder what the next one looks like. What do you think the next one looks like? It's going to be this, right? And it's going to be 1, 2, 3, 4. 1, 2, 3, 4, right? 1, 2, 3, 4. Up, can't. Yep, up, that's wrong. So you guys got 16? And the next one, what do you think the next one's going to be? 20. Okay, so what do you think we should use for a pattern, for a formula? Nice job, because it's like this one. Remember, if you're going up by 3s, you do a 3n. If you're going up by 4s, it's just 4n. Do I need to make an adjuster? Do I need to put a number here to adjust it?
No.
No, because I plug in 1, I get 4. Plug in 2. Nice job, you guys. Nice. Well done. Okay. So for me, the hard part, of course, is always coming up with the formulas. But we can do that.